Another example, remember our first example we had one solution. Our second example had two solutions. When we start a problem, we never have any idea how many solutions. Will it be one? Will it be two? Will it be 8? Will nothing work? Will everything work? Let it play out the way that it plays out. Now, with a rational equation, we're still looking for what works. But the fact that we have the fractions complicates things. That one step. And I'm going to even put it on the back side this time. It doesn't matter what side you put it on, multiplied by the LCD. Now, when we're looking at my denominators, they're already a common denominator. There is no denominator over here. I could think of it as over 1. But again, if I only have one denominator, then that denominator is my LCD. And that denominator is what I'm going to multiply times everything. And it's very critical here. I know from some of those earlier examples when we were adding. When we're adding is when I multiply top and bottom. Right now I'm not adding. I'm solving. There's an equal sign. I'm multiplying everything by that LCD. Meaning, put it over 1, top and top, bottom, bottom. I get negative 6 times x plus 2 over x plus 2. Multiply the top. And again, I'm not going to worry about distributing this time. I could distribute, but remember, bottom times bottom, I get that x plus 2. My whole goal is to get things to cancel. If I were to distribute, I'd only end up factoring it right back out to try and cancel. So only multiply the numerator, multiply this end, and just to show where everything's coming from, I'll put 1 times x plus 2. Because I want to emphasize the point, my equation stays the same. There's still a 1 there. There's still a 3x over x plus 2. There's still a negative 6 over an x plus 2. What I'm doing is I'm taking that LCD and I'm putting it in each numerator. I'm multiplying all of the terms in order to cancel out the fractions. And what I'm going to have here is, when I distribute the 1 now, I mean 1 times anything is just going to be itself anyway, I end up with just a 3x. I end up with just a negative 6. And what's convenient here is, again, all my fractions are gone. By multiplying by the LCD, I get all of the denominators to cancel. And at this point, I do just have a combine and divide. I don't have to factor because I don't have an x squared. And again, when you start a problem, you never really know until you just let it play out the way that it plays out. In this case, x plus 3x is 4x. Combine my like terms, I still have that plus 2. When I want a minus 2 to each side, what I'm going to get is 4x equals, they're both negative, so add them together, negative 8. When I divide by 4, what I'm going to get is x equals, positive divided by negative is negative 2. But now, when I have a negative 2, remember what I'm trying to say is that negative 2 should be what works back in my equation. The problem that I have here, go back to the very first thing we learned about any rational expression. Remember my restrictions? Had I asked you my restrictions at the very beginning of this problem, what you would have told me was, change the sign, x can't be negative 2. If I set that denominator equal to 0 and minus 2 to each side, just like I did at the very beginning, you would have been able to tell me x can't be negative 2 because negative 2 would have given me, negative 2 plus 2, that would have given me a 0 in the denominator. So when I solved this problem, it wasn't that I made a mistake. I did everything perfect solving it. The problem is the method that we use sometimes get us what we call extraneous solutions. Extraneous solutions mean I did everything perfect, but that answer does not work. That answer was a restriction. That number was restricted. It's not that I made a mistake. Now, remember what I'm trying to do is I'm trying to find what works. The only answer that I got didn't actually work. So what I would say here is no solution. No solution does not mean the same thing as extraneous solution. No solution means absolutely nothing's going to work. Extraneous means that number doesn't work. Because if we go back to that other problem, remember earlier when we had negative 2 and negative 3 as my two answers? What will happen is sometimes the negative 2 won't work. That would mean I still have the negative 3 that does. Sometimes the negative 3 won't work. That would mean that the negative 2 does. Sometimes they both work. Sometimes they're both going to be extraneous. When they're both extraneous, That's when I would say no solution. No solution only means absolutely nothing works. Extraneous means that one number, that one number, that one number. Whatever number it is that doesn't work is what we call extraneous. Let's look at another example.